Okay, late night revision. Quadratic functions. How do we summarize this? Okay, so let's dive into the quadratic functions. Yeah, so I'll be going straight to the point so that we don't chat a lot and make the video very long. Okay, so a quadratic function, it is simply a function where we have ax squared plus bx plus c is equal to 0. Okay, so this is the foundation of quadratic functions. The term which has a square, it has a coefficient of a, and then this one x which doesn't have a square, it has a coefficient of b, and then c is a constant. Yeah, so these are numbers a, b, c. All these are numbers. Yeah, this one we call it a constant because it has no variable. A has squared, x squared, b has x just. Okay, so we have formed our foundation. So now we have to discuss now these things. The sum. Okay, so I think I shouldn't have wrapped the quadratic function. Yeah, so we'll need it throughout. So let's we said ax squared plus bx plus c is equal to 0. So I'll have to look at what these things called the sum and the product. Sum and product. So the sum of two roots. So the roots which we're going to be talking about, we're going to be referring to alpha and beta. So these are the roots. Like we can say one root is alpha, the other one is beta. You get that? So when you solve a quadratic equation, you know from the formula you're going to get x is equal to something, or x will be equal to another thing. Yeah, you see that? So these two things which we're talking about, these are, one is alpha, the other one is beta. Yeah, you have gotten the concept. Those values you find, those are alpha and beta. Okay, another foundation has been laid. So now we can get to do something. Okay, so when we're dealing with the sum and product, so for the sum, or first let's also take you back when, if you want to solve by factorizing, we used to have product, sum, factors. You remember these things? Product, we said it's a times c, not so. And then sum will just get b. Okay, so this is supposed to be c. Okay, and then the factors, we get to look for them. Alright, so now want to determine the sum of two roots. So a quadratic function will always have two roots. Yeah, so the sum of two roots, when we say sum, you know it's adding, and the roots, you now know that when we're talking about roots, we're simply talking about alpha and beta. Okay, so the rule is that when you add alpha and beta, so like the sum here, you see it's dealing with b. Yeah, so this is something that should help you remember. So when you add two roots, you are going to get b over a. Okay, so I think I'm proud of myself for saying this. Yeah, this should help you remember, because I remember myself, I used to make a lot of mistakes. Like I would be like, alpha plus beta, uh, is it C over A, or is it B over A? Okay, so I've formed up something for you. Like, remember from factorizing product, it's A times C. For the sum, we get this B. So you just remember that it will be B over A. Yeah, please, you can't afford to forget this. Oh, okay, so that's the product. And then, oh yeah, sorry, that's the sum. And then the product, it simply means we're multiplying. So if we're multiplying one root alpha times another root beta, we're going to get, we have AC. Yeah, so this is why we have C over A. So I really hope that this makes sense. Yeah, like when you multiply, it's simply A times C. So like we're going to have C over A. Okay, so another foundation has been laid. So now, having said that, what can we look at next? Okay, so now we can look at the general expression when we want to form a new root. So you can be given, so like for example, if they tell you that you have been given this is the quadratic function, and then they tell you that can you find the new equation. So the new equation, we get it from what we have done here. So the new equation, writing with a mouse is so boring. Okay, so the new equation, it will actually be, we're going to write it as, we always start with x squared because a quadratic will have a power 2. So you can see this come minus. So we're going to say x squared minus the sum of the new roots. Sum of new roots. You've seen, and then there's one important thing here. So the sum of the new roots, and then you put x outside, so that we can relate to this. And you can also remember from the product sum factors, this is our B. So we have the first thing with a power, and then we say minus the sum B. Yeah, so this minus is from deriving when you do your mathematics deep. Yeah, so this thing I'm writing here is very important. Pay attention. So x squared minus the sum of new roots, and then plus the product of the new roots is equal to 0. Okay, so then you are done. You're basically done. It's very easy. Yeah, but I don't want to tell a lot of stories. Like, let me even give you a baby example. Like, if we have 2x squared plus 5x plus anything 4 is equal to 0. If we want to find the new equation, they just tell you that the roots are alpha and if they tell you that the roots are alpha and beta. So what you're going to do is you're going to be like, Okay, the sum is a plus b. So already answering, you want to form a new equation from here. A plus b, remember I told you it relates to this, the middle part b. So we're going to have a plus b is 5 over 2. This is our a. And then a times b, the product, it is what? So just say 2 times 4. Yeah, 2 times 4, which we can simplify as 8. So the new equation we're going to start, we write the new equation is x squared minus the sum of the roots, the sum which is here, it's 5 over 2. So 5 over 2, and then you just write x plus the product, it's 8. You equate to 0. Okay, this is a baby question. Oh, a baby, how can I put it? Yeah, okay, it's a baby thing. Okay, so that is also another foundation which we've laid. Alright, so now let's go and proceed. Okay, so where are we proceeding to? We're now going to look at, so this is where we're coming from. If you have the chance to, you can be writing. Okay, so we now come to manipulating. Quadratic functions, or all these, the roots and stuff. Okay, so just a minute. Okay, so we have this theorem, something you should know very well. So for the first one, it's I'll show you the simple trick. Yeah, you just have to study these like by heart. So for this first one, it's whereby we have a plus, or alpha plus beta squared. Yeah, so I think I already taught how to go about this, how you can simplify. Yeah, but I'll take you back. So how you simplify things like this, when you have a power 2, you just say e alpha squared. What is alpha times alpha? It is alpha squared, plus what is beta times beta? It is beta squared. And then the next thing you are going to say, this times this. Alpha times beta, you know it is alpha beta. And then you say, since we have 2 terms, we multiply alpha beta by 2, which gives us 2 alpha beta. So like this, you have you have expanded. Some things can be so easy that you even start doubting whether you are wrong or right. Yeah, so this is the simple trick. Let me give you one more. If you want to expand this, so what do? You simply say 2 squared, it's 4, plus x squared, it's x squared, plus You now multiply this by this. 2 times x, it is 2x. And then since we have two terms, we are going to say, also I was even quick to write this. 2 times x, you know it's 2x. And then since we have two terms, we say we multiply this by 2, meaning we're going to have 4x. So when you expand, you can try it, you're going to have this, and then you can just rearrange where you say the final answer is x squared plus 4x plus 4. You just rearrange. Okay, so far I hope so good. So I wanted to tell you the trick on this one. Okay, I'll explain to you for even this other one, so that you don't get stuck. So here we get to deal with like things like what is alpha squared plus beta squared. So from now on, you should always know that this is not equal to alpha plus beta squared like this. These are not the same. Even when we have something different, when we have alpha power 3, beta power 3, it's not the same when you write alpha plus beta in bracket and then there's a power 3 outside. Yeah, it's not the same. So, and this is the interest here under quadratic, like we would want to find alpha squared plus beta squared. So here you can see we have alpha squared plus beta squared, so we can make this the subject. So meaning this guy will go to the other side, you see, so meaning on this other side we have alpha plus beta squared. Here we had plus 2 alpha beta, so we're going to have minus 2 alpha beta. So this is equal to alpha squared plus beta squared. Okay, so this is how they came up with this. Like if we rearrange it very nicely, if we make this the subject, like you can see we have this, which is that. Are you following? Minus this minus that. So you have to know this by heart. But if you can't know, or okay, if you can't remember, then just expand this from the simple trick I gave you. When you expand this side where there is alpha, we are going to have alpha squared and beta squared. You make this the subject, meaning 2 alpha beta should go to the other side. I hope I've made myself very clear. Okay, so this is something to always remember very well. Okay, so we can even look at the other one. I used to have trouble remembering this, but I didn't know that the Pascal's triangle actually works. Okay, so I hope you are done with binomial. So when we have to the power 3, so when we have something to the power 3, we can remember the Pascal's triangle. This is power 0, and then this is power 1, this is power 2, no wonder there's a 2 somewhere, and then this is power 3. Do we remember this very well? So we can write alpha beta. I think this is the exact thing I was explaining in the binomial video. Alpha beta, just like that. And then guys, I hope you remember very well. Yeah, so don't panic. We're together. So this is to the power 3. So always remember that the powers of alpha, the first thing, like previously we're having AB, Yeah, so actually alpha is A, B is beta is B. These are just Greek letters. Yeah, like there's delta. I don't know if it's D. Yeah, so we have delta in Greek. We have letter O. It's om. Yeah, all those letters. Oh, this is an omega. Yeah, letter O is omega. Oh, I don't even know those letters. Omega is the last letter Z. Yeah, so that's unnecessary. So this is simply A and B. So remember the powers of A, they'll start from 3, 2, 1, here 0. No wonder at the far end we're not going to write, there is not going to be alpha because it will be power 0, and anything power 0 is 1. So even B starting from 0, 1, 2, 3. Okay, you have seen all that. So we can write this. We're going to say this is alpha cubed, and then beta is power 0, so it's okay if we don't show it, plus this is alpha, beta is 0, so plus we've come here, we're going to have 3 alpha. Alpha is having a square, B is having a power 1, plus again we have another 3, but alpha is having alpha is having a power what? Ish. Hey. Okay, my village people are working against me. Okay, that's better. Alpha is power 1, beta power 2, plus here at the far end we don't write 1 alpha, we just omit the 1. We pretend as if it's not there. And then alpha is power 0, no wonder we're not going to write it. But B is power 3. So we can collect like terms. Let's take B to come here. So we're going to have alpha square, alpha cubed, beta cubed, plus alpha squared, beta here, plus 3 alpha beta squared. Okay, so the main goal is to have this, to make it the subject. Yeah. So I can take these to go to the other side. Yeah, actually that's what will happen. So like here we have alpha cubed plus beta cubed is equal to, so here I just forgot to write, we had this. This is what we expanded using the Pascal's triangle. So this is equal to that. Are you seeing? So we say it's equal to it's equal to alpha plus beta power 3. Yeah, so have I confused anyone? Okay, yeah, so we're just writing this. Okay, yeah, so I don't want to confuse people. Let me not be selfish. So I'll teach you like babies, although doing it like this makes the videos to be long. Okay, so we want to rewrite it nicely. So let's rewrite plus 3 alpha squared beta plus 3 alpha alpha beta squared. All these they are equal to alpha plus beta cubed. Okay, I think I've done justice. I've simply written these to be on this other side so that we can make this to the subject, simply meaning these will go to the other side. Okay, so we can make alpha plus beta the subject. So when we make the subject, we're going to have alpha power 3 plus beta power 3 is equal to, we have this here. So this is the part I wanted to skip to. So this plus, it will become minus. So minus 3 alpha squared beta plus 3 alpha beta squared. Oh, we're done. Yeah, so where there is alpha plus beta, alpha cubed plus beta cubed, you write all this, and then here we can even simplify further. We're going to have, so this is alpha plus beta squared minus so alpha plus beta squared minus, so here we can factor out 3, and then we can also factor out alpha, because alpha is both sides and also beta is on both sides. Oh yeah, so when we factor out here, when we remove a 3 and the beta has gone, we remain with 1 alpha has also gone outside, meaning inside will remain with 1 alpha. So we'll remain with 1 alpha, we'll have a plus here. So this 3 has gone outside, we have factorized. Also this alpha has gone outside, even this beta has gone outside, but we remain with 1 beta. Yeah, so this is something you should know. So always know that where you have, so like I've told you, under quadratic they'll expected, they'll expect you to work with this, like in their individual form, instead of having this, instead of having a power outside, they want it to be like this. So where you have alpha cubed plus beta cubed, do you know what? Oh, you simply write all this side. Okay, so this was our foundation. It's a solid one. Yeah. So initially I would have just told you to master these. Like, hey guys, master these, we're going to need them. Yeah, because we're going to need them. So master this, also master this. So but if you want, or if you happen to forget this, I remember I used to forget it very much. No wonder I've taught you guys, because as they just, yeah, the lecturer just pointed, oh, there's this theorem, and he proceeded. So what you do, you simply have to expand this. When you expand this, you make this the subject, and then when you factorize, you are getting this. Are you seeing that it's exactly the same thing we have there? Qua, you've seen ka? Even this. Qua, exactly. So I also taught you can expand this and then you make this the subject. Okay, and our colors. So we can delete. Can we delete this guy? Okay, let's take him away. So, and then you might be wondering now why this? Because they can tell you that you have this quadratic expression. You have this quadratic expression, and then they tell you, can you find alpha cubed plus beta cubed? Do you know what to do? You simply have to remember this, which I'm telling you to remember. So like, I know time is not with you, and yeah, Swatilaling you can forget, but I've taught you one or two things. You draw the Kapascos triangle and then you make this the subject. So where you have this, it simply means you are going to write alpha plus beta power 3 minus 3 alpha beta, and then we're going to have alpha plus beta. Yeah, and then it means you are going to work with this, the part in blue. So you have to remember now, Luanda introduced to you what is the sum. I told you the sum, it is b over a. And what is our b here? Our b, it is 5. Okay, so let me spice it up. I put a 2 there. So meaning our b is 5 over 2. If there's no number, it means 5 over 1. Okay, and what is our product? Our product is c over a. Oh, I forgot take a negative. The negative is for the sum. Yeah, so this is negative that. So the product is c, it is 4, a is 2, which you can simplify as 2. So meaning, so the whole lot of this is 2. I hope we're together. I really hope. So this means that here, what is alpha plus beta, you simply put negative 5 over 2. You are seeing? And then we have a power 3 minus, we have this 3. What is alpha plus beta? It's c over 2, which is 2. And then alpha plus beta, negative 5 over 2. Yeah, so Nish, you can evaluate 5 power 3, it is I think 125. 2 power 3, it's 8, minus this is 3. 2 can cancel. We're going to remain with 3 times 5, negative and negative, positive, or 15. Okay, so you are done. This is how you evaluate. I think I've taught you a lot of things just in this introductory lesson. Yeah, so suppose they told you, can you find the new equation? You can always remember, you start with x squared minus sum, and then don't forget the sum, it goes with x, and then plus what? Plus product. Plus product. Yeah, so this will be x squared minus the sum, it's negative 5 over 2. A penyazima 5 over 2 plus product C, it's 2. Always never forget x here. Yeah, so this is how you find. Okay, so this was the basic introduction. Yeah, let's go to the next video now. So I've taught you on alpha plus beta. Always know that it's negative b over a. Alpha beta, it is c over a. The equation of a new root, the new equation, it's x squared minus sum. So the sum will always have an x. Yeah, like most of us will have an x. And then plus the products. Yeah, so I've taught you this, and I've also taught you that alpha squared plus beta squared, it is equal to alpha plus beta, outside there's a square, plus 2 alpha beta. Yeah, master this, very very important. And then if we have alpha power 3 plus beta power 3, I've taught you very well that this is alpha plus beta cubed. So if you forget, you have to expand this and make that the subject. Plus here we factorized, we had here we had alpha plus beta. So I'm leaving you this exercise. What about if you have alpha power 4 plus beta power 4? Yeah, so remember the Pascal's triangle, and then yeah, you just have to expand this power 4, and then after expanding on the right hand side where there is alpha plus beta, when you collect the like terms. Okay, so let me even write it for you nicely. Not Napali Myrat, no, Mr. Mega didn't write nicely, so I didn't submit. If you don't submit, I'll block you. I'm even threatening you. Yeah, so you can try finding this. Yeah, okay, so we end here for this video.